All right, listen up. We are diving deep into the story of two countries, a tale of cryogenic fridges, and how India keeps missing the boat when it comes to scientific innovation. In 2005, Finland's low temperature laboratory, it's a famous lab that specializes in ultra low temperature physics. They brought in a physicist to fix their old cryogenic dilution refrigerators. This person, Rob, got to work, and in 3 years, along with another cryogenic engineer, Peter Wasselman, made a brand new system that was simpler and easier to use than anything out there. Whatever they had made was so successful that they decided to turn this breakthrough into a business. And they founded a company called Blue Force Cryogenics. Fast forward to today, Blue Force is a global leader in ultra low temperature products with about 600 employees, over 200 million euros in annual revenue, shipping their high tech systems to research labs across the world. Now, let's see what happened here. A top notch lab hires a specialist to revamp their tech. This specialist then gets the perfect playing ground to tinker around in, and in the process, he builds the world's first cryogen free cooling system, and then partners with another expert to launch a company that makes millions. Classic industry academia synergy outcome. That's how you do it. Now let's flip the script and look at India. Does India have indigenous cryogen refrigerators? Yes, the Department of Atomic Energy came up with one back in 2017. But here's the kicker, it was 10 years after Finland's breakthrough. And by then, the world had already moved on to cryogen free tech. And get this, even that design isn't commercially available. Are Indian labs themselves using it? No, they are still importing from abroad. In 2017, when scientists from the Indian Institute of Sciences Bangalore needed a cryogenic fridge, they ordered a custom one from a Dutch company called Leiden Cryogenics. And then 5 years later, when IISc needed a cryogen free dilution fridge, they again had to put out a global tender. And guess what? A European company fulfilled it. It's like we are forever stuck in this loop of importing the latest tech instead of building it in house. So we can't build in house tools, let alone make something good enough for exports. So the big question is, why is it that after all these years and with some of the best minds in the country, I mean, we're talking about the Department of Atomic Energy, why is it that we are still relying on other nations to supply essential capital goods? Why are we not producing this stuff in house? The answer isn't simple, but it boils down to a lack of resources, lack of collaboration, and a shortage of hyper specialized researchers coming together. How many cryogenic engineers does India have? I'm guessing not enough. How many labs are doing cutting edge work in superconductivity? So, Finland turned a cool idea into a business that now supplies advanced low temperature products to labs working on quantum computing, fusion research, and other cutting edge scientific endeavors. That's how you turn innovation into a $1 million enterprise and push national advancement forward. It's a powerful example of how academia and industry can come together and create something world changing. But in India, we are just not seeing enough of these success stories. No disrespect to our scientists, they are probably doing best with what they have, but it's not enough. If we are serious about becoming a global superpower by 2047, we've got to close these research and manufacturing gaps. Invest in our talent and start building our own success stories. Otherwise, we will always be left playing catch up while the world moves forward. So, what's the takeaway? It's simple. To dominate globally, we need to train, invest, innovate, collaborate, and create a future where we are not just buying the next big thing, we are building it. For more stories from India's skilling, research, and production trenches, follow Pivot Media.